Welcome to another GCSE Computer Science video with me, Mr Goff, from mrgoff.com. This video will focus on subprograms. Subprograms are self-contained sections of code stored under an identifier that is used to call them when you want them to be run. They may or may not take one or more parameters, which are values passed to the subprogram from the main program. There are two types of subroutines: procedures and functions. Subprograms have a number of advantages, including that they are small and generally perform just one function, so they're generally easier to write, test, and debug. They can be called and run as often as you like in the main program without the need for more code, reducing the time taken to write programs. Subprograms can be saved as modules and imported into other projects, saving time by using tried and tested code. By using subprograms, large programs can be written by different programmers working on their own subprograms. There is one key difference between the two types of subprogram: procedures and functions. A function executes some code and returns one or more values to the main program before returning control to the main program. This means it must be assigned to a variable or variables to store the value or values that are returned when it is executed. A procedure returns no value before returning control back to the main program. It just runs its code and returns control. This means it is called without assignment. The syntax for a function is the function command, an identifier, some optional parameters in brackets. It should be noted that even if there are no parameters passed, there should be a set of empty brackets. Then indented inside that is the code to be executed, and finally a return of one or more variables. So the function multiply num1 num2 that has the code answer equals num1 times num2 and returns answer would accept two parameters of two numbers, multiply them together, and return the answer to the main program. The syntax for a procedure is the procedure command, a suitable identifier, some optional parameters in brackets. Again, the brackets need to be present even if no parameters are passed. And then indented inside it is the code to be executed. So the procedure say hello that is passed a variable name and is asked to print hello and name would print hello and the name that it's passed each time that it's called. The scope of a variable refers to where in the program it can be accessed from. A variable declared in the main program has global scope, meaning it can be accessed in any part of the program, including inside any subprograms. A variable defined in a subprogram exists only within the subprogram in which it is created. It cannot be accessed from outside that subprogram and is destroyed when the subprogram finishes running. It can be tempting to use global values throughout your program so you can access them from any part of the program. This might seem like a valid solution when you're just getting started and writing short programs that you're the only programmer for. However, as programs grow in size, problems will arise. If one variable is affected by several subprograms, there may be unexpected effects, and errors in one subprogram may have knock-on effects on another, making it difficult to locate the errors in your programs. Global variables also have to be in RAM throughout a program's execution. Large programs can have thousands of variables, causing this to be a bigger problem and also leading to naming issues. Parameter passing allows us to access and update variables local to the main program from inside subprograms without the need for global variables. When we define parameters in a subprogram, we are creating a local copy of a variable in the main program. This allows us to create a completely self-contained section of code that is not affected by other parts of the program. Programmers can use any variable they like in local scope without concern of a conflict elsewhere in the program. making naming much simpler. If a value changes during the execution of a subprogram, then we can return its updated value to the main program at the end. In this example function here, num is a parameter that we're passing in from the main program, and choice is a local variable to the function player choice that we then are returning to the main program so that it can be used elsewhere. In the main program, it is possible that the actual value we pass in will be also stored in a variable called num, and that when we return our value choice, it will end up getting stored in a variable called choice. However, this does not have to be the case. Num is simply a placeholder. We can pass it any numeric value stored in any particular variable. So this example here, where we use PC for player choice to store the number they've got, and then we pass player PC to our player choice subroutine, returning choice from the subroutine to the value option in the main program will still work just as well. This can be quite confusing when you first start using it, and the best way to practice is to just make a range of functions yourself. There are a number of built-in subprograms in most languages, and more that can be imported via modules. Built-in functions we have already seen in this course include upper, lower, int, real, and string. Another built-in function you need to be familiar with is random number generation. In OCR reference language, you can use the random command with two integers and get a random integer between those values inclusive of the two numbers that you put in. So number equals random 1, 10 would assign a random number between 1 and 10 that could be 1 or 10 to the variable number. If real numbers are passed, then a real value between the two parameters will be randomly generated. In some languages like Python, the random module must be imported separately. That brings us to the end of this video on subprograms. Join me in the next video when I'll be looking at defensive design. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.